Good day. Welcome back to our YouTube channel. So if you're new here, my name is Tifla. Welcome. So we are just continuing with our free body diagrams and our equations of Newton's laws. So here we are having our objects and we're having our diagram like that. So let's just read the statement, and like always, I'll be showing you the tricks, or I'll be showing you every important aspect that you need to take away from every statement that they give you. So this reads as in the diagram below, an 8 kg block is connected to a 4 kg block by means of light inextensible string. So we already know that if these bodies are connected by a string, it means that each and every block will be having tension. So also it means that this other object as well will be having tension like that. But we already know that they're having mass, so it means that all of them, they will be having Fg, gravitational force. So it means that also block A is having gravitational force as well, like that. So a constant force of 55 Newton is applied to the 8 kg block to accelerate. So it means that this block is having force applied as well, but this object is not having force applied. So the combination of the blocks, to accelerate the combination of the blocks to the right. So it means that these objects will be moving to the right. So this is the direction of motion, that side, right? So let's continue with the statement below. So it also says that the kinetic frictional force between the 4 kg block and the inclined plane is 4 newtons. So we know that the 4 kg block is also having a frictional force. So let's show that this is also having a frictional force of 4 newtons. So already you can see that this is on a plane, so also it will have normal force as well. You can see that. So now we can see that we're having 1, 2, 3, 4 of the forces. Yes, so it's tension, gravitational force, frictional force, and normal force. So the 8 kg block as well, there will be frictional force, because they said while the kinetic frictional force of the 8 kg block and the horizontal plane is 8 newtons, so there's frictional force, and this is also on a surface, so it means that there's also normal force. So let's see how we can draw the free body diagrams of these two objects, and also how you can formulate the equation of each and every block separately. So the free body diagram of this object now, so this is object A. So let's see how we can draw the free body diagram. So we are going to have the object represented by a dot, and straight up we are going to have the normal force. We are going to have the gravitational force, which is Fg. We are going to have the force applied, and I also explained that if you're having the tension of this pulling the object backwards, so it means that this one, the tension will be going to the back. So this is acting as the applied force to this object. So we're going to have tension and as well as frictional force. You can see that this object is having frictional force. So this is the free body diagram of block A. So now let's see the equation of this object. So this object, you can see that we're having 3 parallel forces. These forces are parallel to the surface. So these are the forces that we are going to use to formulate our equation of Newton's second law using these two. So what do we know? We know that our F net is equals to mass by acceleration. So this, we said our object is going to the right, so which means that this is acting as our positive force and these are our negative forces. But before that, it means that we need to do Fa plus frictional force, plus tension will be equals to Ma. Now we need to take care of the direction now. So this will be our force applied plus, since our frictional force is going the opposite direction, negative frictional force plus negative tension will be equals to Ma, like that. So let's go to our object B now. So what do we know about object B? Let's first draw the free body diagram of object B. So object B is at an incline. So let's see. So this will be our object B now. We said what will be of our normal force? It will be perpendicular to the plane. So this will be like the plane now it is. So our normal force will be going like that. But our gravitational force is always perpendicular downwards. So this will be something like that, perpendicular downwards. So this is our gravitational force. And we know that we're having the tension that is pulling this object. So we can put our tension like that. So this tension here, it will be more like the applied force to this object since they are going to the right. And we're also going to have frictional force that will be in the opposite direction of the motion. So this will be our frictional force, like that. So this is the free body diagram of this object. But now, how do we formulate our equation of motion of this object now? Let's see how we can formulate the equation. So what do we know about this? We know that our F net is equivalent to mass by acceleration. So since this Fg is at an angle, you can see that we are having the angle, and we say that each and every body that is at an incline, it has two components. So these components is Fg parallel and Fg perpendicular. And Fg parallel, we said you can find Fg parallel by using Fg sine of theta, theta being this angle, and Fg perpendicular is equivalent to Fg cos of theta. So now, how can we formulate our equation of motion now? So this Fg, it have two components, but you don't need to show them on the free body diagram. But now I'm showing it so that you can see where everything that I'm talking about is coming from. So this is Fg perpendicular, and we can also have Fg parallel, which is always acting downwards the slope. So this is our Fg parallel. So now to formulate our free body, our equation of motion now, it will be, so we can see that now we are having three forces that are acting parallel to the plane. You can see that. So it's 1, 2, 3. So this will be tension plus Fg parallel plus frictional force giving us mass by acceleration. So since our tension is going with the motion, in the direction of motion, it will be positive. So our tension plus our Fg parallel, which will be negative since it is going opposite to motion. So this will be Fg parallel plus negative. Frictional force is in the opposite direction, so we're giving it the negative direction. So which is like that, will be equals to Ma. So we formulated our two equations of motion of these two different objects. So once you know how to formulate this and drawing the free body diagram, you are almost done with how to solve Newton's questions. So I will bring up another question again. I hope you have gained something. If you have gained something, please subscribe to our channel so that we can keep on creating content that you enjoy, content that will make you understand better. Have a lovely day.